and good day to everyone that's joining. Thank you for joining. So today we're going to be talking about something that is very prevalent today. How do we defend against APTs? In the past, most people thought that APTs were only going against nation-state governments, against our government. It is prevalent and it is active against just about any company today, so no one is safe. I've been doing this for about 30 years now, and I won't bore you with my intro or whatever, but I've done hundreds of these different matters involving nation-state threat actors, and it's a real thing. I mean, I'm actively working on a couple of these matters right now where they're actively utilizing things. So the crux of the matter is, how do we defend against these people? How do we utilize the tools that are available to us today through artificial intelligence to be able to go and do better? So here's today's roadmap. So we're going to talk about what the current APT landscape looks like, and why your existing detection approaches may be struggling. And then we're going to talk about detection engineering fundamentals, and then we're going to get into how AI can change that whole mathematical equation for you. And then we're going to talk about machine learning and behavioral analytics, and then we're going to walk through a couple of different real-world scenarios, and then we'll close with some challenges and best practices, and then obviously questions at the end. So let's talk about some statistics around APT landscape this year. Nation-state APTs averaged last year 312 days of dwell time. That's an incredible amount of time for anyone to be roaming through your environment, to be able to know what's going on, be able to see everything, look at patterns, etc. That's almost a year. 68% of them now rely primarily on living off the land techniques. So that means they don't have to have any kind of sophisticated tooling to be able to do their job. That's kind of scary. So that means that you can't rely on traditional indicators of compromise or any other type of indicators. It just looks like normal activity in your network. And so year over year, the automated APT attack tooling has increased 43%. So what that tells us is that the adversary has industrialized, and most companies' approaches to this has not industrialized. So we need to figure out some ways to be able to match what they are dealing with us. So detection engineering is a discipline of systematically designing and maintaining the logic that finds threats in the environment. So it's not the same as buying a SIM tool and turning on default rules. The life cycle on the left shows what mature programs look like. You identify what you want to detect, you design the logic, you test it rigorously, you deploy it, tune it, and measure the effectiveness. And the right side shows the 4 detection modalities: signatures, anomaly, heuristics, AI, and machine language. Each one has a role, and AI and machine language is the newest and fastest evolving. This slide shows us the 6 structural weaknesses that APTs exploit in traditional detection stacks. So signature exhaustion is the most fundamental. APTs rotate variants faster than the industry is able to go and publish signatures. Living off the land is the most dangerous, as we discussed previously. When the attack tools that you are already trusting on the endpoints, it doesn't generate traditional indicators of compromise. Alert overload is the most operationally damaging. So you've got 1,000, 10,000, 20,000 alerts per day that probably get ignored. And then static rule decay is the most insidious. Detection logic from 3 years ago, 4 years ago, it simply doesn't catch today's TTPs. The table on the right is the detection engineering response to APT evasion. So for each evasion technique, there's a detection engineering answer, but it requires moving beyond signatures. The parent-child process anomalies for living off the land, binaries, metadata, cross-referencing, time stamping, protocol anomaly detection for DNS over HTTPS, command and control, impossible travel, stolen credentials, module load, monitoring for DLL, side loading. None of those are signature-based at all. They are all behavioral. And so that's where AI is able to help us extend our ability to be able to combat these threats. This slide shows a moderate attack tactic detection coverage rates. So what we typically see is they actually detect 12% at resource development, 18% at defense evasion at 29. They're not edge cases. They're phases where the APTs do their most critical work. So detection engineering's job is to move these numbers up, and AI will help us by identifying which techniques are missing the coverage and generating detection candidates for them. So if we take this all into context, let's talk about AI transformation. This isn't about replacing your entire detection stack. It's about making a fundamentally more capable stack. So there are 4 capabilities on the right that we'll spend the next several slides on. Machine language powered detection logic that learns from adversary behavior, behavioral baseline analytics that catch the signatures, what the signatures miss, real-time correlation that transforms 10,000, 20,000 daily alerts into 50 actionable investigations for your analysts, and adaptive rule generation that keeps pace with all the evolving TTPs that ATPs will bring. This is the before and after comparison that I want you to internalize. The left column is the operational reality of most SOCs today. The right column is what AI-driven detection engineering makes possible. The shift from the manual rule authoring to AI-generated candidates from TTP patterns alone can cut rule development time from weeks to hours. And so this shift from periodic tuning to continuous model retraining means your detection stack doesn't decay between rule updates. In the last row, 60 to 80% false positive reduction is really what gets your analysts to get a buy-in to AI. This slide shows the 4 machine language paradigms and which detection problems each one of them best solves. Supervised learning excels at classification. So malware versus benign, phishing versus legitimate. Unsupervised learning is your best tool for UBA and anomaly clustering because you don't need labeled examples of attacks you've never seen. Semi-supervised bridges the gap between when you've got sparse labels. Reinforcement learning is emerging for adaptive threshold management. The practical answer for most programs is start with supervised classification and unsupervised UBA, and then layer in the others as your data infrastructure starts to mature. Behavioral analytics is the engine that catches what most signatures miss. So on the left column, it shows what gets baseline: user behavior, entity behavior, network patterns, application sequences, and privilege account operations. The right column shows the detection signals that this produces: impossible travel, lateral movement chains, credential stuffing, data staging anomalies, beaconing, privilege escalation. I want you to notice that none of these require a signature or a known bad indicator. They all emerge from deviations from the baseline. which is exactly how APTs get caught when indicators of compromise-based detection fails. So this is the problem that kills most SOC programs. You have 10 million daily events that get parsed into 50,000 SIM alerts. Your analysts are investigating fewer than 5% of those. AI fixes this through progressive reduction. So you have the correlation that aggregates the related events, risk scoring prioritizes by severity and context, and the funnel starts to narrow down from 50,000 alerts down to 50 high confident incidents. And then finally, the 5 to 10 that actually need immediate attention. The call out at the bottom is the key. 94% workload reduction without sacrificing coverage. That's quantified value of AI-driven alert prioritization. So beyond the signature-based and threshold-based detections, AI gives us 6 additional techniques for catching truly novel activities. So time series forecasting catches slow burn APTs that drift gradually over weeks. Traditional thresholds never fire because the ramp is just way too gradual. Graph-based anomaly detection catches lateral movement by flagging new relationship edges in your network. So a server that never talked to another one suddenly starts talking to them. NLP on logs and command line text catches ossificated PowerShell and encoded payloads. That string misses entirely. These are not theoretical. They are in production at mature security programs today. So detection without intelligent context is detection without attribution. When artificial intelligence has access to structured threat intelligence, so sticks, taxi feeds, ISAC sharing, dark web monitoring, etc., it can do things that signatures alone cannot. It can match behavioral patterns to known actor profiles. It can link isolated events to active campaigns. It can auto-tag attack techniques, boost alert priority when the actor targets your industry, and then draft detection rules from unstructured TI reports via NLP. The last one is the most transformative for the resource-constrained teams. So let's look at a couple of different scenarios. So in this scenario, APT 41 affiliate operator is in an energy company for 11 weeks. No AV detections, 0 SIM alerts. The implant was a WMI based and entirely fileless activity, nothing to hash, nothing to signature. The machine language classifier fired on the WMI parent-child chain anomaly. The UBA model flagged a service account accessing 9 times its normal resource volume. The graph model flagged a lateral hop that hadn't occurred in 90 days. So TI matched the behavioral signatures to APT41's known WMI persistence TTPs, and the containment was in 4 hours, and there was no data that was exfiltrated. Let's look at a second one. Pre-ransomware intervention at a financial services firm. Autoencoder anomaly, it flagged reconstruction error spikes on 3 endpoints. And that means that these endpoints were behaving in ways that the model had never seen in normal operations. The analyst was assigned within 4 minutes. Artificial intelligence pivoted 90 days of historical telemetry and found that there was a Cobalt Strike beacon that had been dormant for 18 days. And the initial access traced back to a VPN credential, a risk score of 97 out of 100. So the ransomware detonation was 72 hours away, and none of this was caught by signature rules. On this slide, we talk about the AI-driven detection engineering workflow as a continuous loop. So designing detections from TTP intelligence, testing and validation using simulations, deployed to the stack, with AI tuned thresholds. In the return path, tune and retrain. That is so important. Tune and retrain the model on new telemetry, and then you measure the coverage delta against the attack framework. These metrics at the bottom are what the loop delivers at maturity: 60 to 80% false positive reduction, 3 times faster rule deployment, and 94% improvement in attack tactic coverage. The loop just runs continuously. It gets better and better over time. Detection engineering doesn't end when the rule is deployed. It connects to the entire SOC workflow. So Tier 1 analysts get pre-scored, clustered alerts instead of raw noise. Tier 2 gets full attack tagged investigation context. Tier 3 hunters get AI-generated hypotheses. And Tier 4 detection engineers get AI-drafted rule candidates for the hunt findings. The right column shows the tool chain: your SIM, EDR, XDR, your SOAR, and critical enabler detection as code. When detection rules are version controlled and get and deployed via your CI/CD, detection engineering becomes repeatable, auditable, and it's disciplined rather than just a heroic effort to go and run after a threat. So there are limitations. It's not perfect. It's not a silver bullet. So data quality is the foundational property that we need to look at. Poor telemetry produces unreliable models, and most organizations underestimate the effort required to get clean, normalized data at scale. The model drift is real, and adversary behavior evolves, and models are trained on historical data. They will lose accuracy over time without active retraining of the programs. Adversarial evasion is not theoretical. There are documented cases of attackers deliberately crafting behaviors to sit just below the machine language detection thresholds. And none of this means AI doesn't work. It just means that AI requires an investment in data quality, model governance, and human expertise. So key takeaways on this. There are 6 things that you need to think about to build into your program. Number 1, detection as code. Version control of your rules. Test them in your CI/CD pipeline. Deploy them the same way you deploy software. Number 2, map your coverage to attack and publish your heat maps internally. Make them visible and let your analysts see the gaps that are preconditioning. Number 3, layer your machine language on top of the rules. Don't replace them. They're complementary to each other. Number 4, integrate threat intelligence into your machine language pipeline for actor attributed detections. Number 5, build a formal feedback loop. Track MTTD, FP rates, coverage deltas, and then feed those results back in to help retrain your models quarterly. And lastly, keep humans in the loop for high impact responses. On this slide, I've got some resources that you can check on. I would start with the MITRE ATT&CK framework for coverage mapping, Sigma for community detection rules that you can adapt almost immediately, OpenCTI for open source threat intelligence integration, obviously CISA for detection guidelines, and Elastic is great for detection rule repository. It's not really specific to a SOC environment. So you just need to take the data and put it back into the loop with the telemetric data that you're seeing. You need to have a human taking a look at all these things, making sure that it's scored appropriately, that we don't see any kind of drift. You need to do a comparison between where you started, where you were last quarter, where you are this quarter. It's not SOC specific necessarily. Yeah, absolutely. So I'm on a matter right now where a Chinese APT is using an exploit against ASUS routers to do SSH credential theft and be able to use residential routers to be able to have as jump off points so that they don't get identified by traditional techniques. So through the use of artificial intelligence, we're able to look at the spread and the patterns of all of these data points coming into one of my clients. And that allowed us to be able to determine that it was an APT versus just normal traffic where people were trying to maybe they have a bad password, the login's wrong, the multi-factor is wrong. Humans, we would have figured it out eventually, but it would have taken us weeks, and instead it took us literally hours to be able to determine through the use of artificial intelligence that this is an APT that's using this specific TTP to be able to do an attack. So it absolutely can get ahead of that and can help you determine what your next course of action is, instead of just looking at different noise and not knowing what's going on for weeks. So this is a common thread that I hear. Everyone's concerned about AI taking their jobs, and the reality is that we have to have humans stay in the loop. We don't want to be living in the Terminator movie where the machines are running the world. We have to keep tabs on things. There are hallucinations that can occur with artificial intelligence, and you can work around those by enforcing models that require evidence of something versus just the AI thought they saw something. So you have to have evidence-based background data. If that fails, that's where the humans add value, because they have to go back in, look at what artificial intelligence has fired on. If the evidence isn't there, they've got to go back and figure out what the attribution looks like. So I don't think that that human analysts are going to go away. I think that what's going to happen transformationally is that analysts are going to be able to scale further out. They're going to be able to manage a whole lot more data, and it's going to be better for everyone. So short term, there may be like some compression on staffing. I think that once everyone figures out how all this works, they're going to see that they still need to have humans in the loop. If you ignore the need for having humans check for hallucinations and keeping humans in the feedback loop, you do so at your own peril. Yeah, so, this question builds on my response to the last question, which is you have to make sure that the way that you've got your models built out, that you enforce that there has to be evidence-based data for actions to be taken. If there's not evidence, then it needs to get kicked out to a second level analyst for review to make sure that it's not a hallucination. Hallucinations are real, and that's just part of where we're at right now. As time goes on, and as you start to build your models and retrain your models, it's going to get better and better and better. The other reality is, on the other side of the equation, the same is happening for the threat actors, right? They understand what we're doing, how we're doing it, and their use of AI is going to get better and better and better. So there's always going to be humans. We always have to look at those outliers on what doesn't have data that supports the finding, and it's just a reality of where we're at. I'm not going to endorse a specific artificial intelligence engine. You can use any of the commercially available artificial intelligence engines, or you can build your own. I've built out plenty of different offline artificial intelligence engines that sit in their own little box, and they're agentless, but they're able to go and process things at speed and be able to do detections and all that. You just need to go and do some research on the different ways that you can do that. I would, if you're new to this, I would go and look at Ollama. Ollama has a bunch of different models that are available to it. Each one of the models have different strengths and weaknesses on how you want to utilize the artificial intelligence engine. And you should research those, and, in your lab, look at how each one of those have pros and cons for you. But there's a plethora of different artificial intelligence engines that you can utilize to be able to feed in both direct feeds and then also using programmatic or API interfaces. Utilization of artificial intelligence is going to increase your alert volume, right? That's going to be dependent on the inputs that you feed into artificial intelligence. What you need to be looking for is, when you're doing your retraining or you're doing your monthly or quarterly reviews of the metrics, you need to see what your false positive rates look like. You need to see what your hallucination rates look like. Those are the types of metrics to look at. When you have that telemetric data from what's coming out of your artificial intelligence engine, you can go and then take those data and retrain your AI model to get better and better and better. And you just tell it, look, you failed on this, right? Look for this TTP that you missed, and here's what you need to look at. Artificial intelligence is not the equivalent of like the universal brain. It only knows what it's been trained on. So if you see patterns that need to be recognized, you just need to, train your model and let it know you're consistently missing, X. It will get better and better and better over time. Yeah, so this is pretty simple stuff, right? If you load all of the different TTPs that all the known APTs utilize into your model, and it's trained on all the attack profiles, it's going to be able to see all of those latent activities. It's going to see all those behavioral drifts that are happening over time with respect to utilization of living off the land tools. That is really where it shines. And, time and time again, we see where artificial intelligence is able to prevent ransomware activities because it's able to look at all those behavioral drifts that are abnormal activities that humans and normal SIM and SOARs are going to miss. So it's already here. There's not a single AI model that is specifically trained, at least I'm not aware of, for use in cybersecurity. Certainly, any of the major XDR platforms, SentinelOne, CrowdStrike, etc., they all have their own artificial intelligence engines that are able to use that telemetric data to help you figure out and do those type of prediction analytics on any type of ransomware activities. So there's not a, just off the shelf AI engine that's just purpose built for that. But there are platforms that you can use that will help you get there if you don't want to build it yourself. Absolutely. Absolutely. You know, I'll say it time and time again, humans have to stay in this whole feedback model. Humans have to be the ones that are arbiters of how we approach the most complex of problems that are there. Artificial intelligence is there as a tool to help humans get faster. It's not a replacement for humans. We always need to have humans in the loop. And that's a great question. And thanks for allowing me to reinforce that. I don't think that Mythos is a marketing hype. I think that those complex artificial intelligence engines are in the wrong hands, and with the proper prompting, they can be extremely dangerous. On the flip side of that, if we have access to those types of models that are that powerful on the defensive side of things, we can go tit for tat on what the threat actors and other nefarious individuals are trying to bring our way. It's going to get really interesting, and I know I've said on previous webinars, we really are in the age of where it's going to be machine versus machine. And if you don't embrace that, if your organization does not embrace that, you're going to get destroyed. It's just the reality of it. We have to use tools that have equivalency to the tools that threat actors are using against us. And it's not going to stop. Sticking your head in the sand isn't going to help you. We're here. So, yeah. Again, AI is not going to replace the analysts. AI is going to allow the analysts to be able to do scale. So, you know, it's just that simple. It allows for efficiencies. Humans are not going away. Analysts are not going away. We still need people to go and look at things that look anomalous. We still need people to go and look at things that get flagged as hallucinations. Analysts are not going to lose their jobs over this. They're going to be more efficient. Yes, so that's really a major strength of artificial intelligence, is being able to take all that telemetric data over the course of, let's say, 120 days and look at the different modalities that are present within an environment. So yeah, they can look and see over the last 120 days or whatever you define. Joe, in accounting, typically at the end of the month, we see a huge spike in traffic that goes out. And then we see all these different things. Artificial intelligence is able to look at these like really small trickles of telemetry and figure out whether or not that is normal. Where a human, it's going to be a lot harder for a human to determine what those little small changes are, especially when you're using, living off the land techniques like a lot of these threat actors do, most of them do. That's really where artificial intelligence shines. You're not going to be able to use your traditional SIM tools to be able to go and do that type of detailed work and understand from a behavioral analysis perspective how this is changing and what's normal versus not normal. So yeah, this is classic use case of artificial intelligence. What I said previously in the last question, it's like taking a look at all of those different telemetric data and understanding the behavior of things, right? Machine A, it suddenly starts beaconing and looking at different things on your network, and it's never done that in the last 300 days. all those little small tweaks that you're not going to necessarily see as a human. Most SIMs, you're not going to be able to go and train to go alert and fire off of that. Certainly your XDR platform is not going to think that that's abnormal because you're using the tools that are built in. AI is going to be able to help you determine from a behavioral analytics perspective that doesn't look normal, right? This file server has never spoken to this other file server. And all of a sudden we start to see these things and patterns. So that's really where AI is going to be able to help us. Yeah, so in my presentation, I showed you, kind of the funnel effect of where we start out from a data and alerting perspective and how it gets funneled down to something that is actionable and reduces the majority of the noise that's there for the analyst to go take a look and do actions upon it. Certainly artificial intelligence is going to help reduce that alert fatigue because it's able to go and do all those different triage techniques that would either A, get missed, or B, would cause you to have to increase your staff exponentially to be able to go and look at those. Yeah, my closing remark is what I've always said about artificial intelligence over the last couple of years that I've been presenting on it. Don't be afraid of artificial intelligence. It's not going to take away your job. It's not going to replace humans. Look at it as a force multiplier. That's really what it's there for if you use it correctly. Also, know that it is imperative that you utilize it because the threat actors are absolutely utilizing it. So it's like bringing a stick to a gunfight, right? What are you going to do with a stick and somebody has a gun? It's really that extreme. So don't be afraid, and just know that the humans always need to be present.